We're doing a lot of exciting work at Rally on the Red Pill team, finding insights in the data. This little video is to serve as sort of a primer for you understanding what those insights mean and how to interpret them. So the general idea here is that we've been making recommendations in the Agile world for quite some time now, without a lot of evidence to back them up. Now, most of those are turning out to be true as we build more and more quantitative evidence to them. But we've never been able to say before how true they are, how much of an impact a particular recommendation has. And that's an underlying theme for this work. This will give you the ability to convince management to move resources or to motivate your team to bear the pain, sometimes painful, cost of change. And so that's the underlying motivation here. We're using this and we're introducing this open sourcing, essentially this framework called the Software Development Performance Index to do this, and this little concept, this little idea called ODM that I'll explain both of those in a little bit, help you gain feedback, make better decisions, increase your performance. So one of the reasons I want to walk you through this particular little intro is that there's a lot of fear out there. There's a lot of poorly done measurement. And if you do measurement the traditional pre-Agile way, you're bound to fail in an Agile environment. And the recommendations I have in this deck essentially help you to avoid that. So I have another deck, another presentation called The 7 Deadly Sins of Agile Measurement. But sin number one is essentially that you should never use metrics as levers. You should only use them as feedback. And the difference here is that feedback is used to improve your own performance, and levers are employed to change someone else's behavior. It's a subtle but important distinction. I'll sort of illustrate it here in the next few slides. So this is an example of a lever type metric. We have a scatter chart here where time is on the x-axis, calendar time, and the time it took something to complete is on the y-axis. They've drawn a control line here, and they've labeled that in red, and they've labeled some dots in red up here. Now, when you do this, what happens the next time you go to show this metric is there's no red dots on it. And it's not because your team's improved, typically. It's because they were embarrassed of being the red dots the last time. And they worked really hard to split their stories and game the metrics so that they weren't the red dot. And the bad part here is that you essentially went through this dance that got you no benefit. But worse than that, you now started hiding information from yourself. Rather, we recommend a very similar but subtly different approach here. We still have a scatter chart with the x-axis being calendar time and the y-axis being the time it took a work item to complete, but there's no red line, there's no red dots. This encourages the team to talk about the metrics, hover over one of these dots, maybe find common patterns, and improve themselves with it. Subtle but important difference. So I said I had another deck that had 7 deadly sins. So this is sin number 1. Certain versions of that deck that's out there that you can Google, the 7 deadly sins, have a different set of metrics, particularly metric number 2. But metric number 2 now that I'm recommending is that you should talk in terms of risks and probabilities instead of making a single forecast. Sin number 3 and so on through 7 also gives you some recommendations. Please go ahead and look at that deck when you get a chance, or see one of the videos of it, me presenting it out there. I think there's some good information in there as well to help you avoid the dark side of metrics. I'm not going to go over any more details in here, other than to basically just sort of mention that we're doing this to try to avoid those negative connotations of metrics. Another thing that we're doing here to show that metrics are different in an Agile world is that measurement is being used to complement rather than replace qualitative insight. We think this is really critical. Agile was founded on the idea that the folks closest to the work have the most context and the most insight, and they should be the ones making the decision. Measurement should help those folks, not be used as a replacement for logic, their logic. And this is the ODM framework that I talked about. So we have this idea that measurement and visualization leads to insight and the reality of the situation that allows you to make better decisions and then leads to better outcomes and better performance. So if that was all we wanted to say, it would be the MEDO framework, but instead it's the ODM framework. And that's to give you the message that you want to start with the outcomes that you have in mind. Otherwise, you might pick metrics that drive the wrong behavior. So you want to work your way backwards from the outcomes that you want to have, or what decisions would you need to make, or the people in the front lines need to make in order to reinforce those outcomes, the likelihood of those outcomes. What insights would they need to inform their decisions, and then that helps you pick the measurements. So that's why it's the ODM framework, not the MEDO framework. As I said, we've set up this team at Rally called the Red Pill team. These are the members of the Red Pill team. It's in partnership with the Software Engineering Institute at Carnegie Mellon. And the idea here, Red Pill, in the movie The Matrix, Neo could take the blue pill, which would send him back to his blissful ignorance, or he could take the red pill, which was exposes him to a somewhat painful reality. We're hoping that the reality is not always painful in the case of metrics, but the goal of the team is to formulate the red pill for software development so that we can make sure that we're dealing in reality. We're doing this by identifying this balanced set of outcome measures. We're validating that balanced set of outcome measures by correlating them with particular decisions. And then we're providing all of this in a framework called the SDPI framework. We're also going to build products in Rally around this framework. We've got some prototypes for those in the works already. Maybe you'll have seen them by the time you see this video, actually. A few more caveats before you jump in and look at your first insights from the Red Pill team. So there's an expectation that measurement will give you the answers to make all the decisions, and I want to sort of caveat that a little bit and pull you back from that a little bit. If you've ever played one of these strategy games, Settlers of Catan, Puerto Rico, or Dominion, or any strategy game, Monopoly, Risk, you know that on any single turn you're going to make one or more decisions, and in any single turn, you're not likely to guarantee that you're going to win the game or you're going to lose the game. Well, maybe the first choice of position in Settlers of Catan can guarantee that you'd lose the game. But that's rare that would be the case. Usually what happens is that you come up with a strategy that matches your context, that over time, if you make the right decisions that reinforce that strategy, you'll slightly improve your chances of winning each and every turn. Or if you make bad decisions, you'll slightly decrease your chances of winning each and every turn. And the insights we're going to give you are a lot like that. You make a lot of decisions when you set up your software development project and what tools you're going to use and what process you're going to use and how you're going to size the team and configure the team and roles on the team. You make a lot of decisions, and any one of those is not going to make or break you, but collectively they can add up to a lot. Another thing that's critical here is that if the context of yourself, of your situation, doesn't match what the recommendations are, if your instincts tell you, it's completely wrong, then go with your instincts. So if you're given a position in the game that doesn't match your favorite strategy, then of course you have to adapt and adjust your strategy to the situation. If the terrain and the map don't match, then go with the terrain. If the terrain has a cliff right in front of you, but the map says the cliff shouldn't be there, you're not going to step off it. Same thing is true here. If I make a recommendation that in general you'll improve your chances or reduce your defect density, whatever, but that only applies to certain contexts, and you think you're not in that context, then by all means you shouldn't apply the recommendation. So most people want a correlation that looks like this, the high R squared, and that's just not what we show in this research. We see small improvements from a lot of different decisions. So we have these 7 dimensions of the Software Development Performance Index. 4 of them we can automatically extract from Rally or other ALM tools: responsiveness, quality, predictability, and productivity. 2 of them we recommend you get from lightweight surveys, maybe even single question surveys. Customer satisfaction, you can maybe use a Net Promoter Score to do that. That's a single question survey. Employee engagement, there's a lot of examples of employee satisfaction or employee engagement surveys out there. We have a particular 5-question one we like. We're glad to share that with you. We also, in the agile world, we realize that sometimes the most important decisions you make are what you don't build. That you want to make sure that you're building the right thing, not just that you're building the thing right. And so, for lack of a better name for it, I'm calling this the build the right thing metric. Now, I don't have a way right now for you to actually gather that, although we have some hints at it, and we're going to try to explore that in the next year or so. Things like uh, analytics, in-app analytics that tell you what features get used the most, or sort of the avenue we're going on that. But that's all sort of future or on your own type work. What we're going to focus on with the software development performance index work is mostly these four that I can automatically extract from Rally data. And to poke down at these a little bit, we've got responsiveness. We're mostly using the time in process, which is similar to cycle time, for this. Note that this can vary by work item type. So you might want to get a feeling for your time to market abilities by measuring the feature from the decision point that you make the decision to actually build the feature to the time you ship it. And that might be a very different type of measure from a priority one defect responsiveness. We're still using cycle time or time in process. We're still measuring the time from one state to another, but they're different work items, and the states that you're measuring from one to the other are different. So these metrics can be parameterized, and we'll use the parameters most appropriate for the situation. We generally use stories from in progress to accepted for this research work, because that's generally stable for most usages of the tool. But in your context, you could make different choices for that when you implement this in your own team. For quality, for research, we're mostly using the release defect density, but you could use the internal defect density if you knew your team was recording defects in phase, in process. Defect removal effectiveness is also available to you. Cumulative defect aging. There's lots of choices for quality you'll be able to put, but we generally use release defect density for this research. Predictability, we're generally using the variation in throughput over time, but we also have what we're calling a say-do metric being added to the framework, where you record when you think work is going to be done, and then you see whether you met that or not, and you track how many times you changed the due date before it was due, and we come up with a score based on that. So you'll be able to choose that. And we may end up using that in some research, but in general, for right now, the coefficient of variation for throughput is what we use. For productivity, we're not using lines of code, we're not using man hours, we are using throughput trend over time, mostly for the research. Your teams can normalize throughput by team size, assuming that you generally have the same size stories or same size work items, if you want to use this internally. And then maybe you can even normalize that by the average for the whole organization to get some intra-organization comparative analytics. But we're going to use throughput trend mostly for the research. A couple more caveats, and then I'll leave you to poking at the insights here. We have these raw metrics, in this case defect density. We have a 36% difference in defect density for this group versus this group. This group is folks, teams that have pretty much all the work, 90% or better of the work, be done by members that are dedicated to only that one team. This one has some folks that are shared across multiple teams, and at least 25% of the work is done by those folks that essentially live in more than one team. You can see that the quality is much better. The defect density is 36% lower for these folks. And this is the mean release defect density. But once we convert that to a score, and we want to use a score because scores always go from 0 to 100, and you always know that a higher score is better than a lower score. So there's very little need for you to think hard about the interpretation. Plus, we can aggregate them then if they all have the same dimension. It would be very hard to add defect density to throughput, for instance, but we can add a quality score to a productivity score and say that the sum of those could add up to something interesting for you. And that's why it's called an index. But we have some trade-offs, some negatives associated with converting to a score. First of all, we shrink the dynamic range of the variability that you're going to see in the effect group, so that there's only a 21% difference in the height of these two bars. The aqua blue is the quality here. And because we go from 0 to 100, you're generally going to want to talk about the difference in the actual values, and that's only a 10%, not a 10%, I should say, a 10-point difference in the two scores between these two. So uh, again, you have to keep all that in mind when you look at this work, that if you only see a 10-point difference, that could translate to a 36% difference in the actual raw metric. Okay, so that was all the introduction I needed to give you before you go dig into the insights. I'll leave you with this one quote from George Shultz. A fact without a theory is like a ship without a sail, is like a boat without a rudder, is like a kite without a tail. A fact without a figure is a tragic final act. But one thing worse in this universe is a theory without a fact. We've been working in theories and instinct and folklore for so long now. We're starting to interject some facts into the discord here, the discourse here. So please enjoy that quantifying of these impacts. Thank you.